All right, today we're going to talk about a metal that seriously feels like it's straight out of science fiction. It's a substance that completely messes with your idea of what a metal should be, and yet it has quietly become one of the most critical elements on the entire planet.
So let me just ask you this. What if I told you there's a metal that can literally melt from the warmth of your own hand, but is also at the heart of military radar, satellites, and probably the smartphone you're holding right now? Well, that seemingly impossible combination belongs to one element: gallium.
Okay, so first up, we have to talk about gallium's most famous, and let's be honest, most bizarre characteristic.
So, meet gallium, or Ga, on the periodic table. It's this soft, silvery metal, but here's the thing, you'll almost never find it just lying around in its pure form. It kind of likes to hide, in tiny trace amounts, inside other minerals. Now look at this number, 29.8 degrees Celsius. That's about 85.6 degrees Fahrenheit. That is gallium's melting point. Just think about that for a second. That's just a little bit warmer than a hot summer day.
Your body's average temperature? That's around 37 degrees Celsius. So you can probably see where this is going. If you hold a solid piece of gallium, the heat from your hand is more than enough to turn it into a liquid pool of silvery metal right there in your palm. It's an absolutely incredible party trick.
But this metal is so much more than just a cool novelty. Even though it's rare in its pure form, it has become absolutely critical to our way of life. Which begs the question, how on earth does this hand-melting metal get from being a hidden trace element into our most advanced technology?
And that brings us to its really unlikely origin story. The journey from dirt to device is, well, it's not what you might expect at all. You see, there are no gallium mines. You can't just go out and dig it up. Instead, it's pretty much an accidental metal. It's an afterthought, something we recover when we're actually trying to get something else entirely.
So where does it come from? A whopping 90% of the world's gallium is a byproduct of refining bauxite, and that's the very same ore we use to make aluminum for everything from soda cans to airplanes. A little bit, about 10%, also comes from refining zinc.
It all happens through something called the Bayer process. Basically, you dissolve the bauxite ore, then you take out the main prize, which is the alumina. And what's left behind in that chemical soup? Our gallium. From there, it has to be carefully extracted and purified to an incredible 6 nines purity. That's 99.9999% before it's ready for the world of high-tech electronics.
So, once we have this ultra-pure, hand-melting metal, what do we actually do with it? Well, this is where gallium's hidden power really begins to shine.
In its pure form, gallium is really interesting, sure. But in compound form, it's a game changer. When you combine it with other elements like arsenic or nitrogen, you create something called compound semiconductors. You can think of them as supercharged versions of regular semiconductors, and they're capable of incredible performance. These materials, especially gallium nitride or GaN, are the real workhorses here.
For decades, silicon has been the undisputed king of electronics, but gallium nitride is here to challenge the throne. And why is that? Because GaN is just better at what our modern world demands, handling high power and high frequencies. It can do more with less energy and in a much smaller space.
And this improved performance is absolutely everywhere. Gallium compounds are in the high-performance chips inside your smartphone. They're crucial for 5G network equipment. They're the reason your new phone charger is so tiny and fast. And they're in the ultra-efficient LED lights that light up our world.
But its importance goes way beyond consumer gadgets. Gallium is a truly strategic metal. We're talking essential for advanced military radar, critical satellite communications, electronic warfare systems, and even for powering spacecraft and the next generation of solar farms.
And this brings us to the most critical part of our story. Because when a single element is this important, the question of who controls it becomes a matter of global significance. This is the global choke point.
Just take a look at this imbalance. The global production of primary gallium isn't just led by one country, it is completely and utterly dominated by it. That massive slice of the pie belongs to China.
At its peak, China has controlled up to 98% of the world's primary gallium supply. 98%. Let that sink in. That level of market control is almost unheard of, and it creates immense strategic leverage in the global race for technology. And in July of 2023, this theoretical dependency became a harsh reality. China announced new export controls on gallium, and it sent a shockwave through the global tech and defense industries. All of a sudden, the question wasn't if they could get gallium, but how.
And the impact was immediate and widespread. Semiconductor makers needed it for their next-gen chips. Defense contractors needed it for critical radar and communications. Even LED and solar companies were hit. It was a stark reminder of just how interconnected and how vulnerable our global supply chains really are.
Okay, so let's bring all this together. Why does this one kind of weird hand-melting metal matter so much?
It's because gallium is the perfect example of a hidden, unseen link. On one side, you have the world of heavy industry, the gritty, chemical-heavy process of refining bauxite ore. And on the other, you have the pristine, sterile clean rooms where the world's most advanced semiconductors, satellites, and military systems are built. Gallium is the bridge that connects those two worlds.
And that's really the key takeaway here. You simply cannot have one without the other. Our high-tech future is fundamentally dependent on the byproducts of old-school heavy industry. The two are completely, totally interlinked.
And all of this leaves us with a final and pretty critical question. In a world that's built on technology, who really controls our future? Well, it might just be the people who control the rare, strange, and indispensable elements, like gallium, that make it all possible.